Hi, everyone. Super excited to be here, and also quite excited that AI is kind of a spotlight here. So the first talk was also about AI, and I'm really glad that it's getting more attention at every conference, regardless of what this conference is about. And today, this talk is also not an exception. My name is Andrei. Like Kate said, I'm working with dstack. And before that, I worked at JetBrains for quite a while. And working at JetBrains is a dream job because you, as a developer, you can build tools for other developers. And some people actually really like it, which is in my case. Because, as a developer, you not only work to get paid, but also to enjoy what you do. Because in the end, you spend a lot of time with your laptop, and if you don't really like what you do, it would be a disaster. And it just happened that JetBrains, we try to make their developer work more enjoying, to let the developers enjoy what they do. And at JetBrains, I've been working with multiple tools, of course, but for example, the last couple of years, I've been working with PyCharm. Raise your hands if you know or use JetBrains tools. Oh, wow. Didn't expect, honestly. So yeah, I worked with PyCharm, and this gave me a chance to also interview a lot of ML engineers and ML teams that it was almost 3 years ago. You can imagine it was all before the ChatGPT moment. And back then, we actually called it ML, not AI. And this was a unique chance for me to talk a lot and see how, and I was surprised to see how often they actually have to struggle, because as an AI engineer, when you actually work with your model, with your data, and it's not something that you can always do using your laptop, for example, compared to, let's say, front-end development or back-end development, which you actually can do on your laptop. With everything that involves data or AI, there's also infra involved. You need infra, and regardless of how expensive your MacBook is, most often you would need even more expensive infrastructure. And back then, I realized that indeed managing infra is not an easy topic. Also, I'll be throwing questions, so I'm curious if anyone heard of what Kubernetes is. Good, awesome. And who is using it? Oh, wow. Yeah, sometimes I'm a little bit afraid attacking Kubernetes because we actually built a replacement for Kubernetes. And I remember that it was a funny moment when somebody else okay, so you're building a replacement for Kubernetes, but what do you use Kubernetes inside? I'm like, no. Why? All right. And yes, I quit JetBrains more than a couple of years ago to fully focus on dstack, which I'll be talking about today. And we are a small but growing team, and everything we do in open source. And maybe that's a good chance if you can scan and find dstack on GitHub. And then at the end of the presentation, if you really like that, you would probably even give it a star. If not, then just, I don't know. There's no way to get a star. Awesome. And I'll have a, let's say, formal part of the presentation with some slides. And then we'll switch to a bit more hands-on part where I'll just show the documentation and we'll walk you through what this deck is, how it is different from Kubernetes and all. And because we are building a replacement for Kubernetes for AI, I'd like to start with outlining some of the trends that we see happening in the market. And of course, it's not a surprise to anyone that, something is happening, right? So everybody is talking about AI, so there must be a reason, and it should also have some reflection in the real world. And what we can certainly say is that there's a skyrocketing demand for AI infra. Obviously, because everything what happened after this ChatGPT moment, we see a lot of new cloud providers appearing, and Max mentioned Runpod in the previous demo as one of their providers that now challenge hyperscalers. and they actually call themselves Neo Clouds, not just clouds, but Neo Clouds, maybe because it's just cool. On the other hand, it's when you call yourself, when you focusing on GPU mostly, not just on normal things, but mostly around AI. And then it's called Neo Cloud. Of course, so there's a lot of data centers, and we'll see why that's a thing also for data centers. And finally, of course, the accelerators. So it's the time for the accelerators. I mean, probably the best way to prove that would be to look at their stock exchange for the NVIDIA stock. So basically, this is almost 2 years ago. This is when OpenAI released ChatGPT, and you can basically see that it's now 9 times more expensive, the stock, and there should be like a reason why this happened. But what it also means is that there's a huge demand for the infra. Somebody is buying these GPUs, somebody is installing these GPUs, probably those might be data centers, some of these GPUs are offered through the cloud, probably someone is using those GPUs. So that's the implication. And of course now it's not just NVIDIA, we also see other players here in the game. Well, I personally didn't expect to see how well equipped AMD here, and just in time, out of nowhere, they now present this MI GPUs. Have anyone heard of AMD and their latest GPU developments? All right, not very many, but I must tell you, they actually have also GPUs, and they also enters the chat basically, and so we're going to see a lot of development from AMD as well. And of course, not to mention other accelerator manufacturers like Cerebras Systems and many, many, many more. And finally, one more interesting trend here is, of course, the open source. And probably who've ever tried any open source models? All right, there is the room for improvement. Basically, oh, that's AI in action. All right, awesome, thank you. So now open source models also enter the game. And of course, Meta is one of these companies that is pushing this forward with the Llama model. But it's not only limited to Meta, we also see other companies now entering the chat. In exactly a year ago in November, I don't know if you followed, Clem is a founder of Hugging Face, basically the service that allows us to host open source models, to share them with the community. He made this prediction. I mean, a lot of people making predictions. It's a pretty popular game. You don't even have to be right. You just make a prediction, and then some people just forget what you said. However, a year ago, Clem also made a number of predictions, and one of the things that it said is open source LLMs will reach the level of closed source models. Raise your hands if you share this belief. Come on. Good one. It's waits for you. So this is the chart, actually carefully plotted by Maxime Lebon, is an engineer in Liquid AI, if you know. He just puts the timeline for all the models, and on the left-hand side you can see the score. The MMLU, it basically a benchmark that measures how a model behaves on different set of tasks, and also like how well it's at reasoning. And the higher the score, of course, you can imagine that the model is more expensive. Or let's say better, right? And we see that on the, again, left-hand side, we see these closed source models, right? Like the first version of Claude, then GPT-4 is over there. It's like really good, and it was released basically the beginning of 2023. And now we see that on the right-hand side, this. I mean, you don't see the color here, but if you see the number followed by B, it most likely means that it's an open source models, means that B means billions. Billions means parameters here. And you see that as numbers grow, we get better performance. And basically in October, Meta released Llama 3 model, which actually came really close to OpenAI has. And then the process got even faster. And this is like 1 month old slide. So a lot of things you can imagine happened during this month. We got Qwen model by Alibaba Cloud, which actually surpassed the quality of Claude. And then it was they did that by building a model that has much fewer parameters. This is out of the scope for the presentation, but the number of parameters really matters, because the more parameters the model has, the more expensive it is to run that model. The more GPU memory you need, and more expensive the process goes. And the greatest thing about this open source development is that it's not just enough to build a model that beats the closed source provider, but you need also to come up with a fewer parameters, so this model is easier to be used with your data center, with cloud, and so on and so forth. And yeah, basically, just recently, for example, for code generation Qwen, again, these guys from Alibaba Cloud, they released a very small model which actually like beat it, the Claude code generation model. So it's just another way to say that open models are here, they are here to stay, and they rival the closed source models you can imagine. And of course, it's not just open source models, it's also the open source frameworks and tools. You can imagine companies like OpenAI and Anthropic and Together AI and Fireworks and many more. They are called normally managed services. Something like they typically promise you, okay, so just click this button and this model works on your data, and pretty much you don't need to do anything except basically paying for that. And this is called managed services. And now we see that they get very this gets very crowded. A lot of managed services appear, and it becomes pretty reddish ocean. But in the end, most of these managed services actually use open source tooling behind. They use pretty much same like optimized kernels for the GPU. They used same frameworks for fine tuning. They use same frameworks for inference. And this is great because this is by basically giving back to the community. At the same time, they make the core stack more mature, but that also at the same time, it basically the mode shrinks, and it's get more difficult for them to be to compete with each other. But this is exactly what is good for the community. So basically everybody like here benefits out of this process, because running models and training models gets easier and easier. So finally, concluding this list of trends, very important one. So a lot of companies now played with OpenAI, and they now, okay, thinking, we did this proof of concept, so how do we do now that with our data? And like we actually heard with the question at the previous demo, people start to think, okay, so but what about the data privacy? I mean, how come that you can share my data, customer data, with an external storage? So that creates a lot of problems, and that highlights the fact that privacy becomes like a super important topic when it comes to AI, and probably some critical factor here. This is a chart from one of the surveys Anderson Horowitz did in March. They basically sat together with some leaders, with some Forbes or whatever they call it, like big companies. And they asked it questions, basically, what is your plan? So this happened in the beginning of the year. You can imagine with all that development in open source models, how this could change. But basically they asked, okay, so what are your plans? Do you already use open source, or do you plan to use open source, or maybe you don't? So you can see that 41% actually said that they already use it. And other 41% said that they just wait for these open source models to get more mature. And then there was another question in the same survey about, okay, what is the main reason? Why do you really consider the use of open source models? And as you can imagine, I mean, the question was designed the way that first you give like, just choose multiple reasons, and then you say which one is the main one. And as we see, control and customizability are two most popular choices here. First one, control. It's by using open source models, you you can have more control over your model. So you don't depend on an external service provider that can change the behavior of the model, or which is very important. And then also privacy. And then customizability is how easy it is to customize that model. And we know that also in the previous topic, it was highlighted that one of the advantages of the open source models is that you can easily customize, fine tune, build on top of them. So, and then of course, when companies were asked to choose what is the main one, it's control basically. Because imagine yourself as a big business, and then at a certain point, your business starts to depend on the behavior of the model. You basically put the whole business at risk if you make it depend on an external model provider. That's what actually pushes the companies to consider open source. So now you can imagine that a lot of enterprises, they consider the use of open source models, and then they think, how can we use these models in production in our case? It means that the companies need a way to orchestrate these workloads, because now if, for example, you switch from OpenAI or a similar company to hosting these models yourself, then you have a dilemma of how to basically do that at the efficiency that OpenAI does it, for example, in both training and inference. And if you come to think that all those enterprises, they have very different cloud providers, they have different even hardware, the data centers spread in different regions, and they certainly need a common way, kind of a standard developer tool to orchestrate those workloads. And it just happens that Kubernetes by today is the only standard that allows us to manage infrastructure regardless of the vendor, be it cloud or open source. And thanks God that we have Kubernetes. However, when we look at the AI, we see a lot of issues, let's say, or bottlenecks that Kubernetes is associated with. First of all, Kubernetes was not designed for, let's say, AI tasks. It was mostly designed for DevOps tasks, where the main use case is they're deploying the production code over cloud and on-prem. That's why the abstractions that Kubernetes offers, they are a bit more low level, and you at a certain point have to choose. Either you are an AI engineer or you are a DevOps engineer. And it's really hard to actually do this both. And also worth mentioning that with Kubernetes, Kubernetes is a low-level abstraction layer, which doesn't come with AI essential tools. As an AI engineer, for example, you need high-level abstractions for managing clusters. Now I need this cluster, tomorrow I need that cluster, and better not doing it with, well, creating a Jira ticket, then going to your data platform team, and then talking, exchanging emails with them, finally to tell you to hear that, well, it's a bit difficult to arrange that cluster for you. So this is, I mean, exaggerated a bit, but that's what AI teams often have to go through, because, well, all of that is managed by the MLOps team. MLOps team is in charge for managing your Kubernetes cluster. And it just happens that there are very few, and you are AI developer, part of a bigger team. You see, basically, we actually call it MLOps tax. A company, in order to use Kubernetes for ML purposes, has to pay MLOps tax. Means you have to hire DevOps, you have to hire Kubernetes people, you have to invest heavily into that, and then ML community doesn't stand still. The stack actually evolves pretty quickly, so your MLOps team is under heavy pressure. And this what hinders most companies to actually, do a lot of development, use more expensive hardware, and do basically ship AI into production. And finally, to mention that while Kubernetes is a vendor agnostic standard, you can think that you can use Kubernetes with AWS, with GCP, with Azure. However, when it comes to AI, what we often hear from teams is that, sometimes you actually want to use several clouds because of the availability of the GPU and everything. And then also sometimes you actually want to use on-prem. And Kubernetes might allow you to use particular cloud or on-prem, even though with on-prem it's not that also straightforward. But there is no possible, it's not possible to use multiple clouds or hybrid, for example, cloud and on-prem. So that's one of the issues with Kubernetes. Right, and well, with the rest time of this demo, I'd like to talk more about what dstack is, and for that I'll probably switch to the documentation, because that's the best way to explain what dstack is and walk you through the use cases. All right. So once again, when at the beginning of the presentation, I said that we're building an alternative to Kubernetes and Slurm. But let's now focus not on Slurm, but on Kubernetes more. And just like Kubernetes, dstack is a container orchestrator. So how many of you ever used containers? Oh, wow. I mean, what are you doing? Basically, I don't have to explain what container is. Maybe just mention that, well, we all use containers because it's the easiest way to pack your dependencies and be sure that it's going to work anywhere, doesn't matter where you run it. And then somebody or something orchestrate these containers. And I would just say how many workloads I need, or at what scale I should run it, or at which infrastructure provider I should run it. And then this something will basically implement that, or orchestrate that. And this something is called container orchestrator. When we are using Kubernetes, this container orchestrator is called Kubernetes. And if you come to think, then each cloud provider implements this managed Kubernetes. For example, when you start using Kubernetes with AWS, it means that there's somewhere on the AWS side, there's this container installed. You might also know about this control plane that is in charge of what is running. But normally, as a user of a managed Kubernetes, you don't know that. You basically just use the service by a cloud provider. Or if, for example, you are very brave and install the Kubernetes on-prem with your own cluster, then basically you install that software and you have to manage it, or buy some expensive, or maybe close to expensive enterprise offering for on-prem. But basically, what I try to say here is that just like Kubernetes, dstack is also a container orchestrator. But let me walk you through some of the differences. So difference number one is that the number one thing that dstack we consider very important is vendor, to be vendor agnostic. That's why when we design dstack, we chose deliberately that we don't want to rely on the vendor for the managed service. We want you to be in full control. Basically, it means that you install dstack wherever you want. Could be your laptop, or it could be dstack, it could be some server, and then you point it to the cloud provider or to your on-prem infra, and then you don't depend on them. But dstack basically is able to provide you control plane for that. But I'll explain more what that means. Another one is because we built a container orchestrator for AI, we basically built in the accelerator support as a first-class citizen. Means that when you run something, you actually specify exactly what kind of accelerator you want and what kind of VRAM you want. With dstack, you would probably need to use custom operators and then label nodes and invent certain kind of things. Right. The best way to explain dstack is to walk you through the process of from how you install it, how you configure cloud, to how you actually use it. So in order to use dstack, of course, you have to install it somewhere. And the easiest way to do that would be by using pip. You just pip install dstack, and then you invoke this command, dstack server. This command basically starts the server where you run it. And it, as I said, it could be your laptop, or it could be somewhere in a cloud environment, or in your data center. And then that is it. So there's a control plane running available at this address. Now, anyone who is given access can basically use the CLI or API or dashboard to interact with that server. So let's now talk a bit about the cloud support. In case you'd like to use dstack to orchestrate your cloud workloads, you would need to configure so-called backends. There are multiple ways to do it, but the most simple one and straightforward one would be just create a YAML file where you basically give their credentials and other settings to dstack. And this way, dstack understands, okay, so now for this project, the user configured, the admin configured AWS account, configured whether I have to use some VPCs or not, basically just provided these settings. And on the right-hand side, we see a list of cloud providers here. These are the cloud providers that dstack supports out of the box. And because dstack is an open source project, it is possible to extend dstack with more cloud providers. And as you see here, for example, runpod is just one of these providers. Basically, if you just open this file and configure your runpod credentials, then dstack would be able to now orchestrate and scale up and scale down these workloads in runpod as well. And this would be very close to using, for example, serverless feature of runpod, with the difference that here you have this infrastructure as code paradigm that everything goes through dstack apply, but then you also have a flexibility and of switching between cloud providers and have same functionality with any other cloud providers, and then also combine this also with on-prem. Which we'll talk about hopefully if we have enough time. But this is only to say that dstack allows you to configure multiple cloud providers. And this is very easy to do. You don't need to do anything. You just need credentials from the cloud provider, and you can configure as many as you want. So now imagine that you've created that file, you started the server, and then you brought the users, let's say AI team. So now they can use the CLI or API to basically run their workloads. If, for example, we compare dstack to Kubernetes, where with Kubernetes you have this low-level abstractions like pod, like replica set, like load balancer, like for traditional development. When it comes to AI development, you typically thinking of something more simple. And let me walk you through this concept that dstack offers, and we'll start from the most simple one, like trivial ones. Let's first start with the dev environment. Sometimes, not very often, but sometimes you actually need some interactive environment. You just say, okay, so let me just use my IDE with this GPU or with that GPU. Let me use my notebook or whatsoever. It's just that I'm going to use in my laptop, but I need some hardware that I don't have locally, but I still would like to use interactive way. With dstack, everything goes through the configurations, and you just create a configuration called dev environment. You specify the requirements. You can choose your Docker image, your dependencies, and then, of course, the resources. And there's a very rich syntax of how you can ask how many GPUs, what kind of GPUs, what providers. And then what you do dstack apply, and then dstack looks at what cloud providers are configured or on-prem clusters, which are also mentioned hopefully in a while, in a moment. And then dstack either reuses some of the existing capacities that are there, which we call fleets, or it provisions them on demand. And then it offers you this URL which you can click, so you can access the dev environment through your desktop IDE. And work with it as it runs locally. In fact, that it runs in any configured cloud or on-prem cluster. That was easy. Now, what about more, let's say, complex task? Now, let's imagine that you want to run a web app or a batch job. Let's talk about the batch job. With a batch job, it could be either one node batch job or it could be distributed batch job, like, for example, fine-tuning. You have your script, you have your Docker image, or you don't have a Docker image, but you know what libraries you want to use. And with that, you just specify the type of the configuration task, specify the requirements, and then you specify the commands, what to run. And this can be any commands that run either locally or through SSH. There is no need to change any code. You just specify the commands, and then, of course, you also can specify the resources. Maybe mention very quickly that dstack out of the box supports the distributed tasks. Imagine now it's not enough to have one node with 8 GPUs. You'd like to use 2 nodes with 8 GPUs each. And then all you need to do is to specify these tasks. And then dstack allows you to use this, what we call system environment variables, where dstack automatically propagates. It basically, dstack thinks, okay, you need a cluster of 2 nodes, and I'll provision that. I'll ensure that it's highly interconnected cluster. At the same time, what I'm going to do, most likely you're going to do something distributed, means that there's going to be a head node and then workers. And then it basically provisions those nodes, and then it knows this is a head node IP address, those are worker nodes IP address, it knows how many GPUs per node, and then whichever distributed framework you use, Ray, Spark, Torch Run, anything, they all support this notation, and all you need to do is just pass this as command line arguments. And then this stack would basically, once it provisioned that cluster, then it would just run the head node script, and then it will run this worker script, and that's it. The framework, the dstack framework, the dstack orchestrator itself doesn't have to know anything about it. It just orchestrates the actual distributed framework which you use. For example, in this particular case, we are using Torch Run for fine tuning. But let me go back. Once you define that task, you again using dstack apply, and then this works pretty much same way. If there's already provisioned cluster, then it just uses it. If there's no one, it will provision that automatically, and then it will run the script. You are also allowed to use any ports. You can also use tasks for running web apps. Imagine that you'd like just to run, I don't know, Streamlit app, let's say. It just, you need resources. You would, let me show you how a web app would work. So here's a Streamlit app. You just say, okay, type task, this is my requirements, and basically just use Streamlit hello. And then you specify, okay, I need those ports to be forwarded. And then when you do dstack apply, dstack CLI would automatically forward those remote ports of your Streamlit app to your local machine, because it runs it in the attached mode. And you can access this Streamlit app as you run it locally. Basically, you can actually click localhost colon 8501, and then it will access the remotely running Streamlit app, which is pretty powerful and simple. And it allows you not only to run web apps, but also any kind of jobs, regardless of how complex those are. For example, with AWS, if a cloud provider supports this infinity band or some other fabric, let's say that allows you high interconnection between GPUs of the nodes, the stack would provide that automatically. You just, if you are using an instance that supports that, it would work out of the box. And then in that case, fine tuning would be extremely fast. Right. Now, let's speak very quickly about services. All right, so we've fine-tuned something, we've experimented with the model. Then imagine that you'd like to just run inference for a model. This is how you do it with dstack. You define again the configuration file where the type is set to service, and then you can again specify any requirements, and then you're free to use any serving frameworks. Like, for example, we know VLLM, TGI, there are many more that you can use, and you have full control over that. It's just that now you specify not many ports, but one, because it's a service as an endpoint. dstack will auto-scale it. And then you can also register if you want this is as a model, and then dstack would basically provide you this model through a common gateway. If your team deployed multiple models, you basically utilize those models through an OpenAI compatible interface, basically as you're using OpenAI within your team with multiple models deployed. Right, again, you specify the resources. Now, when you run it, obviously, dstack allows you to access that endpoint through the dstack server proxy. Dstack server by default proxies the traffic. However, if you'd like, for example, to configure a more sophisticated ingress, then you would create this gateway configuration, and you can configure it in many different places you want with clouds. And then dstack would let you handle basically their custom domain, HTTPS traffic, and everything else as you want. But you don't have to do it for development purposes. If you are only developing and not serving any models in production, services is just enough, and it works out of the box. All right, maybe we're getting there. One more important thing to mention here is that whenever you are running something with dstack tries to reuse an existing fleet. I mentioned that dstack needs to provision some capacity, and this capacity is called fleet with dstack, and dstack uses these backends, cloud backends, to provision that. For example, if you configured run pod or Lambda, dstack would provision these fleets in this particular cloud provider. And then if you, for example, stop something, dstack by default keeps this capacity idle in a pool, and then if you run something again, and if this fleet is idle, it will reuse that, and you can configure for how long time it stays idle. For example, by default, it stays idle 5 minutes. If you don't use your instance again, the stack will automatically turn it down, so you don't pay for that. However, you can, of course, configure for how long it stays. However, in certain moments, you would like to have a tighter control over that, like how much it stays idle, or which particular setup for this cluster to use, whether to use interconnected or not. So you'd like to have a tighter control. In this case, you could create this fleet configuration, and you could also tell, okay, what exactly you need, and then you invoke dstack apply, and dstack would provision that fleet and make it ready for you. So whenever now you run anything, dstack would reuse this fleet out of the pool, which gives you this tighter control over the life cycle of their, let's say, fleet. For example, if you are managing a lot of workloads and you have certain rules when you'd like to provision and deprovision your infrastructure, you would be able to use these fleets to basically optimize the costs for the cloud use. So now, finally, imagine now the situation when you'd like to either combine the cloud use with on-prem use, or just go with on-prem and run your models or like training workloads using your on-prem like GPUs or machines. And typically with the Kubernetes, that would require you to manage that on-prem cluster and actually use it. With dstack, we try to make it even simpler. So imagine that you'd like just to use these two hosts that are within your network. They are already set up with GPUs. And you actually have a private SSH key that gives access to those nodes. With dstack, you would create this fleet configuration, and you would add this section SSH config, where you would list the hosts of these on-prem machines and provide the SSH key, and then you would do dstack apply, and dstack would automatically use the SSH key, would connect there, and you'll see this particular cluster as your fleet. So now whenever you run something, you are able to run your workloads using this on-prem fleet. So as you see, you need 0 MLOps engineers, you need 0 DevOps engineers. And your AI team can do development, can do fine-tuning, can do deployment of models at scale without any, let's say, internal development. So this is, and at the same time, you are able to reuse multiple cloud providers. You can use them in parallel to help with the availability and costs, and then you can also combine that with on-prem, which must be much easier than Kubernetes. So it is not possible to cover everything, but dstack has other concepts as well, like for storages and for like permissions, like things like, for example, in Kubernetes, like namespaces where you can isolate different projects from each other. But that's not a lot. A quick check, how much time do we have? Do we have like 5 minutes, or we do? All right, just to give you a demo. So let's try to use it. So here we go. This is the, let me restart it to show how it works from the scratch. All right, you typically, Imagine a very simple case. We have some cloud account. It could be Runpod, or it could be some other provider. In my case, I'm using now Lambda Cloud. but it's pretty much similar to run pod. What I'm going to do is I'm going to install, of course, dstack. Let me necessarily not update. Let's just install it. So now I can just start dstack server. As I mentioned, dstack server by default reads this configuration from this file. And if we open this file, we're going to see that, look, there's one project only. It's called main. We configure backend type Lambda, and we provide a Lambda API key. Hurry up to make a photo, and then you can use GPUs for free. Right. So now the server is up, and it means that we can use that server through the CLI or API or through the user interface. The CLI basically looks like this. So this looks a bit somewhat in the direction of Kubernetes, but it's a bit simpler. And then if we open the URL, we see that it comes with a control plane. Basically, you see all the projects you've configured. We have only one here. We can see, existing volumes, fleets. We see all their runs. We can configure projects, and every user has a token. It's not possible to use dstack without a token, but that allows to manage permissions and really know who is doing what within your AI team. So now dstack server is running. Well, just 10 minutes before this presentation, I actually created a fleet out of this configuration. I just, here I have one node, and I just say, okay, so give me A10. And then I use this apply command where I pass this fleet configuration. So because I actually ran it 10 minutes before the presentation, it shows me that, okay, so fleet is already created, no changes detected. Now if I use the dstack fleet command, it's going to show me that, okay, so I have this instance already idle state. And it's there until I decide to kill it. I didn't configure any idle time. If I've configured idle time, then dstack would basically count moments to turn it down. And so now means that I can use somehow this little fleet of mine. So let's start with a very simple one. All right, what do I have here? Okay, so here we go. This is the dev environment. I just say, okay, so give me any GPU from 24 to 80 gigabytes. I'm going to use Python 3.11, and I'm not using any custom Docker image. If no custom Docker image is specified, the stack uses its own with the configured drivers. So now I do this. Reuse is just a flag to ensure that no fleet is created, and I'm reusing one of the existing ones. This is when dstack basically decides whether I have to provision anything or whether I can use one of the existing ones. The provisioning works this way that if we provision, dstack would use their cloud APIs to provision that VM or bare metal for that matter. And then it would install dstack shim. Dstack shim is an internal component that takes care of the status of these containers and everything, and then it would run the container. And the CLI on the user side will basically handle the port forwarding and everything else. So now as we see this URL basically telling that, hey, this dev environment is up and running. So now we just click the URL and the desktop VS Code ID basically automatically connects to that remote instance. Great. And we also can see that dstack automatically took your repo from your folder where you invoke dstack apply, and it automatically synced this repo with the remote machine. So now we're on the remote machine, but we have all the files that we had in the folder, including all the local changes. If you change something and do dstack apply, and this will reflect in any remote environment which you run. And of course, if we run the NVIDIA SME, we're going to see that basically we actually have this A10 instance. But again, this is just to demonstrate how dev environments work. We just stop it. And then when I stop it, dstack cleans up. Dstack tracks all the hardware metrics, all the logs. And then when your instance is even killed, you'll be able to watch what happened there. Right. Dstack, like if anyone used Docker stats, the command that allows you to see what's going on in terms of metrics inside the container, dstack actually has also such a command. It just takes the run name, and then it also provides you how much GPU is used and other metrics, which is pretty helpful when you do development. So now maybe final one, 2 minutes to count, right? So let's go and run something cool. So here's a Llama configuration where I'm just using VLLM. Let's just go ahead and run it and see what happens. Llama. Cool. We're going to reuse the same instance, and for Llama, 24 gigabytes would be just enough. Right. Maybe while we see that is getting launched, a quick one. We're going to see the fleet here, and it's shown as busy. If we run something now, dstack would show that we either provision a new one or just don't do anything because this one is busy. Now we also have here models. If we specify certain service as a model, it means that we register that as a model, and means that we'll be able to use that model through the user interface, or of course the OpenAI compatible API. If we click run here, we're going to see the logs here as well, and all their state, and you can also manage things there. If you have a project, then you would see all the runs from your team, but you won't be able to see or manage anything in the project that you don't have access to. Right. Have to wait. Pip install is the slowest thing here. Even model is downloaded faster than pip install. Right. Maybe while we wait, dstack also allows you to manage cache. This is what lets you optimize the inference time, like cold starts and everything. We can actually see how it works here. Llama. If we see here, we specify not only the requirements and commands, we also specify volumes here. Here we can use either network volumes, basically to persist something in the cloud, but we can also persist something inside the host. In this particular case, we mount the Hugging Face cache folder to the instance folder. And now if we rerun the same model on the same instance again, dstack would need to download the model. You would just reuse it from cache. So now we see basically that it's running. And if we switch to the user interface, we're going to see that this model is running, and we can do basically this to check that it works. So this is Llama running in Lambda Cloud, and you have full control over that through the CLI and user interface. And with that, happy to see if you have any questions. Thank you.
Are there any? Pizzas are getting cold, so two questions.
And sorry, everyone, that I stand it between you and food.
Hey, so what's the catch? What's the paid features of it?
Paid features. You wouldn't believe if I said There's none, right?
I don't know.
Thank you.
I'm waiting for him.
It just happens that we do have only one paid feature, even though it's not possible to find on our website. But we now have some big companies that are using dstack, which we are helping, of course, use it. And so far, the only paid feature they ask us for is an integration with single sign-on. dstack itself has this authentication, and you can manage tokens manually. But for some companies, they just want to integrate. I mean, you can even integrate it yourself using the open source one. But with enterprise, it's just there.
I get it. Thank you. Don't forget to revoke your API key.
Thank you.
Any other? Go ahead.
Oh, okay, thank you. Yeah, thanks for that presentation. I'm just curious about, you mentioned that it's possible to handle like different cloud providers in one time. And also I noticed that there was some like cost labels that show the price. It is possible somehow to set up that it will, for example, say, hey, buddy, for example, this cloud provider is out of money. We can, maybe let's use this one.
Yes, that's out of the box.
Oh, nice.
If you configure, for example, run pod and Lambda, dstack would automatically offer you, we call them offers that are cheaper. It will pick any that satisfies the requirements. You don't necessarily have even to specify the version of, the name of the GPU. You can say, okay, so CUDA compatibility version this, and then VRAM from this to that. dstack would automatically collect offers from multiple providers and will offer you what is available, and it goes one by one. If something is not available, it will, you can even configure that retry policy. For example, you can say, okay, I need that particular instance now or tomorrow, just go for it, get it to me. And then dstack eventually will get it and will run what you want. Right, and you also see the price. And actually another one which some companies ask us for is being able to manage these team quotas, because they don't once again wake up and then just see out, even though that can be managed with the cloud providers as well. But yeah, totally.
Thank you.
Right.
The last question.
Where's pizza?
Thank you for the speech. I have a question maybe about installation process. It looks so painful. Did it available under Nix package manager?
I'm sorry, say it again.
Did dstack available under Nix package manager?
Good one. No, but we accept pull requests. Seriously, I mean it.